we have another in the series of neurosurgical hangouts for the Neurosurgical TV conference on brain tumors, and we have the honor of having Alvarez Pinzon, MD, a gentleman who we met originally in Miami when he was working at Lockton Hospital. Now he's doing a fellowship up at Johns Hopkins, and he'll tell us all about that. And first, we'll introduce Simon Downs. Hi, Simon.
Hello, good evening. It's very wonderful to be here again. I'm looking forward to the presentation. I'm in Tokyo.
Very good, Simon, and great background. And Slaven.
Hello, everyone. My name is Slaven. I'm here in Croatia, and I'm looking forward to your great presentation. Very nice.
Thanks for coming, Slaven. Okay, Andres, can you say a few words about yourself, what you're doing, and then you can go into your presentation.
Okay, perfect. Hi, good evening, everybody.
First, excuse me, Andres, you're on the screen share. We can't see your face.
Okay, let me see here.
There we go.
Okay.
Okay.
So, can you see me here?
Yes, we can see you. We can see you.
Okay, perfect. Hi, everybody. Good evening. I just want to first say thanks to John for the invitation to allow me to be a part of this project. It's a very interesting project, and I'm very happy to participate. Well, right now, I'm just doing my postdoctoral degree, my postdoctorate in neuro-oncology at Larkin Community Hospital. But in the same time, I just got the invitation for Johns Hopkins to do a master degree in biotechnology and neuro-oncology. So I'm very happy to participate what I find in the last 6 months about research, about the outcomes of neuro-oncology, and actually to share with my college everything I know in a library. So I apologize maybe because the sound is not so good.
No, thank you.
I'm very happy to be here.
Thank you.
All right, so today I just want to talk about the biotechnology. I just want to talk about the relationship of biotech and neuro-oncology, and how can we use the current practice of the systems, of the informatics systems, to practice the neuro-oncology and actually to practice the neuroscience. So first, I just want to start as a real quick presentation about what is biotechnology exactly, what it means, and actually what we do right now. So let me share here. This is the first presentation.
Okay, you can see it fine.
Perfect. Can you see my screen?
You slipped off the screen share.
Okay, right now?
No, you're not on the screen share yet. No, not yet. You were on it, but you fell off. Okay.
All right, let me look it out real quick.
Yeah, the Mac is a little weird.
Yeah, I know. Sometimes I'm just trying to. Okay, so let's see here.
Okay, don't worry, we got time. Plenty of time.
Giovanna's desktop. What about now? Can you see the presentation?
No, yeah, I can see it now. Yep.
All right, perfect. All right, wonderful.
Beautiful.
Perfect. So first, what I say, I want to talk something about the biotechnology. What is the real practice of biotechnology now in 2016? How can we use the new systems and new technologies to improve the quality of life of the patients? So I'm going to talk real quick about the principles, application, and neuroscience in biotechnology. So what is biotechnology? That's the first question. Biotechnology, you can define for the use of all of the new systems, all of the new computers, all of the software definitions to improve, to help the health science, to help the biology in a new system, in a new world. So the general definition is the application of the technology to improve a biological organism. Any organism can be researched, can be found by different types of biotechnology. It's not only neuroscience, it's not only medical background, it's just all of the health science. So the definition is the application of the technology to modify the biological function in the organism by adding genes for another organism. But the next question is, how can we apply these principles? Or what is the definition to imply biotechnology? So is the nature has a rich source of variation. Here we see bean has many cycles, colors, and patterns in nature. We can see how the bean will changes for around years. And right now, what is the type of food that we consume in the normal life? The next question is, the nature doesn't contain or does not contain all of the genetic variation that man desires. Why we say that? Because in the normal life, we can see different fruits with vaccines. We can see how all of the alimentation, all of the nutrition change in different times of the life. So we can see that one of the most important things of what we eat every day, that is the rice or maybe the fruits, we see that it's not the same rice that we ate 20 or 30 years before. Right now we have many changes in what we eat, and actually we have many changes in what we see in the world. Why? Because everything in the time, because the genetic desire, because the genetic evolution was changed. So what is the improvement right now is because we have the technology. By biotechnology we can study not only the disease, talking about health science, we can study all of the elements of the nature. We can study all of the changes for the last 20, 30 years. Actually, we can study the DNA, not only for humans, for all of the mammifers in the world, and actually we can study the DNA for all of the virus. We can study all of the things that is very important, because sometimes we only not find the cure of a disease, but we can find using biotechnology the new disease, what can be, how can we prevent, how can we treat the infections. And actually, if we see in the normal life the grains, talking about for grains, how the grain was improving in the normal life. So right now we say we look words like I say gluten free. We see words like I say it's not GMO, it's GMO. So some things that is happening for a lot of years, and we see that they have a relevance when we see GMO, non-GMO, and oncology in cancer. So that's the start of the biotechnology, just to improve the quality of life using the systems, using the technology. As you see here, another question is, what control this natural variation? What is the control of the all of the improvement, all of the movement, all of the civilization for each part of the world, for each part of the science? So we have different allelic, we have a allelic difference at genes who control a specific trait. But what is that? So can we see, for example, if we're talking about medicine, what is the variation of P53? What is the variation for the cell cycle? What is the variation of all of the points for regulation of the cell cycle? That is very important because it's one of the basis of the science. And actually, when we talk about neuro-oncology, we see the P53 is a marker that is very important to treat and actually to prevent a lot of cancers, not only for neuroscience, just for all of the humans, different types of the body can have problems in P53, in S3, when another, when interleukins or immunity disorders, that everything is related by genes and everything is related for all of what we eat, all with the source of the medications or the source of what we eat every day. So the definitions are needed for this statement. What they say in the books. The gene is a piece of the DNA that controls the expression of a trait. We know that. But actually the allele is the altered forms of the gene. So the alleles is what in the changes of the time, the allele can be changed. The allele can be shows changes not only in humans, but in all of the species. And that's why we just see that many of the species are changing in the last 20 years. And actually, we see that right now, many diseases are coming from animals, are coming from the nature, are coming from infections that never been happened before. For example, the H1N1, we don't know exactly how they came, but we know now that it's a virus, that happening because they changed the alleles, they moved all of the alleles, and that's why that was very hard to treat in the last time. So what is the difference between genes and alleles for Mendel's traits? There is a question just in the basics. I just want to talk for this about very quick and actually no, I don't want to be more deep because it's something that is just for biotech, but it's something to we need to know. So the Mendel genes. So we see here a comparison: the plant height and the size of shape. So what is that? So here in my left, in your left, you can see the plant height. You see how a plant can be tall, and you see how the plant can be short. But what happening because they have a mutations, or they have a transgenics, or they have a molecular work that happening before the plant grow. That's why the size of the plant is different. And when we eat, many of the nutrients that we eat right now, that's why we need to ask, this was genetic related, or that's the normal that have to be tall or short? So why? Because in the future, actually right now in these years, we see that people who eat fruits that is GMO, that is molecular changes, that is no, that they don't have any molecular, they have molecular changes. Actually it's very bad for the life, and actually it's very bad for the health, because they make changes in the future, they make changes for the nutrition, and actually it's a risk for the future for many of the oncological disease. So that's why right now we are in the mode to everything have to be non-GMO, have to be gluten free, have to be many things that actually for the inflammatory markers are helpful when you eat that type of food, not when you eat food that is came with some molecular changes. Right now in the next slide, you can see why this implies a genetic continuum. So what is that? If the molecular change happening, everything can be changed, and disease can be changed, the infection disorders can be changed, and actually will be hard to treat infection disorders or many other genetical disorders. Why? If you're talking about penicillin, for example, the penicillin that we have discovered more of the 30 years ago, right now is some complex to treat patients with only penicillin. The amoxicillin don't have the same outcomes that have before 10 years ago. Why? Because the resistance is very high, because the molecular changes are resistant for all the markers to the cell wall that they have the penicillins. So that's why the biotechnology in this time of point is very important. Why? Because when you use the systems, when you use the bioinformatics, for example, you can double check the DNA and RNA and see how can you treat the patients in terms of the infection disorders and how the molecular can be changed to treat and to get out infections. So when you see here in the slide, this implies a genetic continuum, so a direct relationship exists between the gene, the alleles, and the phenotypes, the difference for all of the traits. So what is the phenotype? So it's all of the representation of the molecular, but in the phenotype, in the outcome, in the normal representation for the life. Let me move here. So here you can see a real example, the allelic difference for Mendel genes, plant height gene. So we need the gene, we see the gene that is gibberellin 3 beta hydroxylase. There is something G that we studied before in the lab. So the fusion, very quick, is the acid oxy group to the GA20 to make the GA1. They say the role of the DNA, and actually they say the mutation that they bring to the gene to can help to grow very real quick the plant. But actually that mutation could be a mutation to help a disorder in the future. So that's what is the question. So we need to use transgenics, we need to use that type of mutation, or is better to be like 50 years ago that everything happened normal without humans' hands in the fabrication of the foods. So what is the central dogma for molecular genetics? So they say the principles, and actually this is very important when you're going to talk about the neuro-oncology, or when you're going to talk about the radiosurgery, or when you're going to talk about all of the infectious disease. Porque because the guiding of the principle that controls the train expression, you can see here the DNA, the genes, how the transcription go to the RNA, that relation to the protein, and the protein to the trait or to the phenotype. But if we have many changes between RNA to the protein, we can translate to many disorders that you see right now, because the beta thalassemia, that is one of the most typical disorders for blood, they have a translation between the RNA and protein, but in the same time, we can use the biotechnology to can bring the gene that is necessary to improve, to help to support the quality of life. Most of the time, beta thalassemia major. So that's one of the most important examples to the use of biotech. In the same time, you're talking about neuro-oncology, we see how the glioblastoma multiforme can be treated using the biotech, and can we treat to improve the outcomes. So right now, if we're talking about biotechnology, and the another side that I see that is important in the same time is the plant biotechnology techniques. Why? Because that's something to happen to help the nutrition of the world, and actually we need to know and be aware about the gene manipulation. So the gene manipulation identify a gene from another species which control a trait of interest, so to help and to support the growing process, or modify an existing gene, so create a new allele. So it's something that if you see in the gene introduction, they introduce the gene into an organism, and this technique is called transformation, and forms the transgenic organisms. So it's something to happen every time, everywhere, for all of the plants and for all of the nutrition and for all of the elements that is fabricated using transgenics. So the gene manipulations start at the level of DNA. That type of DNA is manipulated for all of the source, and all of the source to can help and support the growing process. So you know that the DNA is in the nucleus, that they're going to contain heterochromatin, euchromatin, all the things that we see in the basic science. But the thing is, when the DNA is packaged, the double-strand DNA can be transformed using molecular abbreviations, and actually at the same time, the chromosomes containing genes can be added to support the changes, or to support to what people want to see. Strawberries more biggest, or fish more biggest. So some things, sometimes some common thing like that. But the situation is how they're going to change all of the quality of life of the humans in the future. So if you ask me how the genes are cloned or how they based off, so the genes are cloned based on similarity to known genes. So the homology of the cloning, so mouse close using to obtain a gene. In the same time, the genes can be cloned using a protein sequence. So the complementary genetics, and actually this protein sequence is very important, because when we have disorders that they have problems in the receptors of the cells, we can do a protein sequence to complementary helps and reports outcomes, better outcomes, using the gene sequencing to help the receptor to be performed using the genes, to put the gene in the nucleus, or sometimes we can put a receptor in the cells using the biotechnology, doing research by biomarkers and see how can we put a new biomarker in the cells. But right now I want to tell you something that is very important is regarding the neuroscience. I have a very quick here a presentation to show one of the most important disorders, and actually one of the most important treatments, talking about neuroscience and talking about one of the most important tumors. So let me show you here real quick one of the research that right now is presenting today for Dr. Jose Valerio in Brazil. He's presenting this. We are the PIs, the principal investigators, for the impact of the preoperatory application of the carbon-stim wafers in combination with temozolomide and gamma knife radiosurgery in high-grade gliomas. I don't know if you has listened before about the glioblastoma multiforme. of the GBM. This is one of the most devastating disease, the most devastating cancer, talking about neuro-oncology. Why? Because the quality of life is very low, and actually the mortality rate are so high. It's around 90% of mortality around 2 years. So as you see, it's one of the most hard disease to treat. So that's why we did a prospective observational study. I've been following using the biotechnology, evaluating the outcomes, doing bioinformatics, doing research, but all of the PubMed sites, and actually looking the outcomes because right now many people use radiotherapy, and other people use just temozolomide, and other people use radiotherapy only carmustine. But in this trialing based of the experience of Dr. Icy Wolf and the experience of Dr. Valerio, we just complete observational study and we evaluated the outcome. So what is the impact when we use temozolomide, when we use carmustine, when we use gamma knife radiosurgery? So as you see here, I just want to define first the incidence of this type of tumor. So 3,000 cases of primary brain tumor diagnosed in the United States each year. Primary CNS lymphoma is around 7 for 100,000. Colon cancer is 60 to 100,000. But this type of tumor, GBM, is the 10th most common cancer in the United States. So what is the classification of the brain tumors? So we see the astrocytes. So the characteristic is star-shaped cell astrocytomas, which is one of the most common tumors. Oligodendrocytes that possess few dendrites, oligodendrogliomas, and the ependymal cells that line the ventriculus to ependymomas. Let me move here back. So how we grade gliomas? So the glioma grade 1 to 2 is a well-differentiated low-grade astrocytoma. Then the portion is 50 to 20%. The grade 3 is anaplastic astrocytoma that is 30 to 35%, and glioblastoma multiforme is the most devastating disease that is grade 4 that contains the 40 to 50% about gliomas. The median survival. So what I say in the study of the practice, the importance of the histology gradings, that is very concerning because in the terms of the grade we can see the survival rate. So low-grade oligodendroglioma, they're going to 4 to 10 years, low-grade anthracytoma 5 years, anaplastic oligodendroglioma 3 to 4 years, anaplastic astrocytoma 3 years, and as you see in the last line, glioblastoma multiforme is less to 1 year without treatment, or sometimes with treatment, because sometimes we have a brain tumors to grow very, very quick, and actually it's not sensible to radiotherapy, not sensible to temozolomide, so it's devastating disease. So what is the difference between primary and secondary GBM? The primary GBM develops the number of glial cells. Everything you can follow that type of things using biotechs. For example, in bioinformatics, you can see how the primary GBM can be comparable to secondary GBM. So you can see how they develop the number from glial cells and how the secondary GBL develops from low-grade or anaplastic astrocytoma. How do you do that? So you're going to compare the DNA, and you see the type of growth and the type of the cell and the cell nucleus. So that's why it's very important to have the biotech base and in the same time the clinical base. In primary GMM, so that accounts for 90% of the biopsy resected cases. In secondary, 70% for lower grade gliomas developing to advanced disease with 5 to 10 years of diagnosis. And the clinical history is 6 months in primary, and secondary compromise less than 5% of the GBM cases. That is something important that is the age related. So the median of age in secondary GBM, the diversity is 45 years. So it's young people to have that type of disease, and that occurs in less than 1 year. So it's a consideration to do clinical trials to help and support the quality of life, and actually if we can find some cure. So that's why we just complete observational study to see what is the outcomes, how we improve the quality of life, how the success rate using the gamma knife radiosurgery in the same time using temozolomide. What is the presentation if you ask me about the brain tumors or GBM? So the patient can with headache, can be have seizures, motor weakness, altered personality, loss of memory, dizziness. That's the typical presentation, but actually, as you see, many people could have a headache, so that's why it's very important to go to the neurologist or to neurosurgeon as soon as you have very complex headache, once you have recurrent headaches, so that is very, very important to consult early. So what is the MRI description of features of glioblastoma multiforme? So it's rapid progression, enhancing tumor, surrounding edema, and it's 5% is multifocal. As you see here in the right side picture in the top, you can see a lesion in the left parietal area can convert more like a 30 to 40% of the brain, and actually they're doing compression to do a lateralization of the brain tumor. And actually, in the same time, when you go to the image in the with the image in the second part downstairs, you can see a lesion in the top in the right side, and the lesion is compressing and actually is doing some compression to the brain stem. Current treatment or gold standard is surgery to try to reset as much as you can. Radiotherapy, radiosurgery, chemotherapy, and the novel TTF. The novel TTF is one of the most new therapies using the technology to help and support the treatment of brain tumors, and especially glioblastoma, because they stops the cellular progression, they stops the cell cycle. As you know, the brain cells, the neurons, don't do any cell cycle. So in the same time, when the people use Nova TTF, there is a device to have to put in this outside of the school, most of the time 20 hours a day. So they helps and support to stop all of the cell cycle in the cells of the brain. But between the only cells in the brain that is doing cell cycle is the cancer cells, the cells that is doing mutation. So it's very important device to treat, and actually they have many randomized studies right now to support the science of this type of device and actually to help to improve the outcomes in the normal tumors. What is temozolomide? So it's chemotherapy. It's a methylating agent. The principal mechanism is causing damage to the DNA of the tumor cell, leading to cell death. They take orally, rapidly absorb, penetrates the blood-brain barrier, and those according to the body surface area. The side effects, well, tiredness, nausea, constipation, low blood counts, and particularly, and you see the CBC, a particular lymphocytes ready for pneumocystis carrying pneumonia, and in the same time, the another symptom is the rash. Right now, the standard treatment of GBM, what I said before, is open surgical resection, the radiotherapy, concurrently with temozolomide, followed by 6 weeks of telozolomide, and the new thing shows the gamma knife radiosurgery. So gamma knife radiosurgery is technology. So it's a device that you can do treatment for multiple lesions in the same time, in the same day. That is something that you can do by radiotherapy because you need multiple sessions. You can be very precise, very in the point when you need to do the treatment in the lesions of the brain. And actually, I can say the side effects are actually the radiation is less when you compare it to continue whole brain radiotherapy. That's one of the gold standard right now. The whole brain radiotherapy helps, and I can say that it's not help because that was the gold standard. But actually, in the same time, we see that using radiosurgery, the outcomes could be the same or could be better, and actually the side effects normally will be less. So what is the outcomes? When you're using the literature, you can see one of the most first research that is came from 1994 from the Journals of Principal and Neurosurgery, when they say the outcomes are very poor when they do only surgery. Surgery plus radiotherapy is only 9.25%. And surgery, radiotherapy, and chemotherapy just 10%. So actually, it's not helps. But now, we can see reporting in different journals. For example, this one in the New England Journals of Medicine in 2005, a phase 3 trial study evaluating the GBM radiation plus temozolomide. And we see how the outcomes improved, and after weeks, we can see related a concomitant temozolomide plus radiotherapy and adjuvant temozolomide for 6 weeks versus radiotherapy alone, and we see how the group using temozolomide improved after 30 weeks, but the radiotherapy group doesn't have any improvement. Here you can see the comparison in a scale, in a visual scale, how the yellow graph, that is only radiotherapy, just have a survival rate for 12 months, so only 1 year. By using radiotherapy and temozolomide improves to 14.6. So that was statistically significant, and it's something that you need to be aware when you treat patients with brain tumors, to try to do the less risk and actually to try to get the better outcomes. So that was the basis of biotech. What is the indication for temozolomide? We do a recurrence of anaplastic astrocytoma, glioblastoma multiforme. So right now, I'm going to talk about biotechnology in terms of pharmacy and Gliadel. I don't have any financial disclosures. This is a prospective observational study from academic points. It's nothing to be pharmaceutical things. Just to do observational research. That's what I like to do, and that's what I do normally. It's nothing financial to disclose right now. So that's what I say that, because I'm just going to talk about the use of Gliadel Wafers and the experience for Dr. Valeria doing this type of cases. So the surgical implantation of chemotherapy Wafers Gliadel is implanted to tumor by the time of the surgery. So when you do the surgery, when you go to do the tumor resection, you need to implant this type of medication that helps to treat the brain tumor, and actually it's a chemotherapy related to the surrounding brain tissue over a period for 2 to 3 weeks. And the clinical trials in the last 3 years show survival benefits. When you see here the patient, you can see how the gliadel, that is the white thing, go directly to the brain, can be implanted and closed. Gliadel is indicated for use as an adjunct to surgery to prolong survival in patients with recurrent glioblastoma multiforme for whom surgical resection is indicated. For example, we have a study, the name is study 9003. 22 patients was enrolled. There was a multi-center open label phase 1-2. We have a study 0190, 32 patients enrolled, multi-center randomized double-blind placebo-controlled phase 3, and the study T301, that is a multi-center randomized double-blind placebo-controlled phase 3. A total in total to 294 patients who was evaluated related the use of these medications and the treatment of glioblastoma multiforme. So the Gliadel wafer is indicated for a use of treatment for significant prolonged survival and maintain overall function, and actually in the same times to treat the malignant glioma and propose or to support to improve the quality of life. This is a biodegradable polymer. Copilamine contains 7.7 milligrams of BCNE wafer. The local delivery of the medication is over to 2 to 3 weeks at the high tissue level. It's not detectable systemic, and no additional surgical intervention is required. So you can see here, Wafers are there. You can see here the presentation. And now this study is very interesting. So if you see here how the implant surgery helps, supports, improve the quality of life. So we're starting at a standard point of 100%. So the patient came to surgery with no other side effects, just with the symptoms of clinical symptoms for headaches. And actually, in the past of the months, around 4 months, 3 to 4 months, you see very important decline of the neurological function. But when you see the glial, you just can see that they still have some declination, but they still have a difference in the quality of life. The quality of life from the implant of the surgery, the survival rate is better, is more using Gliadel. The clinical experience today, so more than 6,000 patients have been treated with Gliadel Wafer today, not for our center, for all of the world, for the current clinical trials, and well tolerated with attention to postoperative management of cerebral edema. This is one of the most important side effects, and that's actually that's why we recommend to each case is different, each life is different, each person is different, and each case have to be evaluated for a multi-center program of neuro-oncology to see what can we use to improve the outcomes and actually to cure. For example, it's in cases that we see for GBM that is not necessary to implant this type of gliadel. But we've seen in other cases to do temozolomide treatment, to do treatment with a gamma knife radiosurgery, and actually at the same time using the NOVA TTF. That's one of the current protocols in Miami Neuroscience. For GBMs, they do the evaluation with Dr. Wolf, they do the gamma knife treatment, and at the same time they start the treatment for temozolomide for the same stop protocol, and in the meantime they start to use Nova TTF. We see right now very outcomes. We see that how the quality of life is preserved to the patient, and actually they don't have the side effect to have many patients with the radiotherapy. So right now the phase 3 study for T301, so confirm the safety. That's one of the newest studies from 2014, confirm the safety and efficacy for results. They fully define safety profile in primary surgery and then determine instead of clinical benefit of survival, maintaining the status, and actually they helps and supports the time to progression. This is the same study, this is another clinical trial. For example, in this trial you see a comparable for 16 to 16 patients, one using Gliadel, one using placebo. And you see the mean age that is same, you see the millimeter square that was the same, the histology that was the same, the number of Wafers that was the same. But actually when you see the ratio, you see that in the first line, the Gliadel versus placebo can help the P is significant. So it's P008. So it's a statistically significant change when they use Gliadel versus placebo. The conclusion for this study is that Gliadel in conjunction with surgery and radiotherapy decreased the risk of death by the 63% in patients with newly diagnosed malignant glioma. So that's why, in base of this study, we just started the protocol, use the protocol for the gold standard treatment to help to support the quality of life of the patient for the standard of care, to start using gamma knife in specific cases. In the cases that we can't do radiotherapy, they do gamma knife radiosurgery, and actually that's why we just look it up, how they heals between, not just for the use of the Gliadel, not just for the use of temozolomide, not just for the use for the no-TTF, just the outcomes to use radiosurgery and see how the patient improves and how the patient can get a better quality of life. So here, for example, you see an image showing the study and see how the lines, the outcomes, the hazard rate per person per year is different between the two cohorts. So when you see the black points, the biggest, highest points, is that's how the treatment go to the left, and when they go to the left, and they see a better outcome, better survival rate, and most of the time is when they use this type of medication. Let me show you here. Alright, so this is a study. Let me show you here real quick. finish right now. So here, for example, you can see the comparison of post-operative surgical scissors. So you see that in all of the studies, the first one, the Cavactor study, Broyles for LR, for Cavactor et al., for Samagerol, all of the studies show the incidence of seizure is less. They don't have any difference. This is the same time of treatment for Gliadel. This is the summary, the risk ratio. Now let me show you real quick what we find in our clinical study. So we do first a retrospective study, level of evidence for. We analyze the charts from 2008 to 2013, and actually for the last year, just for 2015 and 2014 to 2015, we found 31 subjects with a new diagnostic glioblastoma, and actually who undergone a craniotomy tumor resection. 2 was considered to be macroscopically complete in all of the cases. All patients with the were subsequently gamma knife radiosurgery in the first month after surgery, followed by sacrosuccinylmolamide for adjuvant treatment. The mean number of adjuvant temozolomide was 7. But what we found? We saw that the mean age of the moment of the diagnosis was 56.4 years, but the median overall survival rate was 20.1 months. So if you're going to compare for the another studies, you see that using this type of technique is comparable to use of radiotherapy. And actually using gamma knife, they don't have the side effects of the radiotherapy. And in the same time, if we use the new technology, the biotechnology, and multi-center studies to help to improve the quality of life for each case, we can use the newest technology, the highest technology to help to improve the clinical outcomes. So that's the main idea of this talk. That's the main idea of this study. If we use in the same time biotechnology, the neuroscience, the clinical science, the neurosurgery science, and one compendium for each person, for each patient, we can support and we can help to improve the quality of life. That's the main objective and that's the main result of this type of studies. Actually, everybody can say, well, it's just a retrospective study. They have a lot of bias because it's just a chart study. It's just sometimes you see the variables can change. I say yes. Yes, it's just a retrospective and then observational. But in the same time, it's just the start to see we can improve, or actually we can start a new randomized study with some follow-up for 2 to 3 years. We can see we can do some studies that just not compare when you use carmosine. They just can't compare when you use radiotherapy or gamma knife radiosurgery. We just compare the resection. We just compare the time of the diagnosis. Many things can be comparable, but actually when we do that to compare radiosurgery versus radiotherapy, when we compare the use of carmosine or not, we will see difference. So that's why my proposal to start a prospective randomized control study to evaluate the use of radiosurgery versus radiotherapy in the treatment of glioblastoma multiforme. And in the same time, depends on the cases, we can do a case control study to see how the outcomes to use the carmosine wafers. All right, so this is my talk. Thank you very much.
Very good, Andre. Thank you very much. And I'd like you to meet Luis Ordonez Solario. He's a neurosurgeon from Mexico City. This is Andres Pinzon. Luis.
Hi, Luis. ¿Cómo está?
Can you're muted, Luis.
Yeah, I think
Yeah, he's
for
muted.
everybody.
We've done a couple of hangouts. There you go. Hey, Luis.
Good. How are you guys? Congratulations, Andres, for your talk.
Yeah, I wanted you guys to meet each other, and the reason why we're late is because Andres was so dedicated that his computer wasn't working well, so he went to the local library to make a connection with the computer, and we really appreciate that. And we'll shorten this up. Simon and Slavin, do you have some questions or comments for Andres?
Thank you very much for your presentation. It was very interesting, and I'm noticing that so much progress has been made in the last 5 years. I'm wondering, what do you expect or hope to see in the next 5 or 10 years?
I think the molecular treatments
To-
to improve the outcomes, doing treatments from the DNA, doing treatments from the microtechnology could support and could help. So I think the next 5 years, we're just going to see changes in terms of biotech for the cellular treatments, but actually in the same time, we have a very important topic that I didn't relate that this talk, but it actually is very important, is the stem cells treatments. The stem cells in one of the newest technologies that actually University of Miami, in Johns Hopkins, and in many other universities in the world is doing many treatments for the using the stem cells. So that's one of the another changes. And actually, I think the gamma knife radiosurgery will be so important. And actually, right now, it's a very good device to use in many treatments. It's not just for brain tumors. It's not only for trigeminal neuralgia. It's many treatments that using minimally invasive surgery can help and support to do a same or better outcomes with less side effects.
Thank you very
Okay.
much.
Slavin, do you have any comments or questions?
I just want to comment very shortly. Thank you on this very nice presentation. It had so many parts. It was so interesting, and you mentioned also the treatment for the glioblastoma. I was fascinated by the numbers you showed. There was no evidence of possibility to survive more than a year. Still no treatment possible.
Right. Well, when you go to the research assignment point, you see that many of the current articles say that uh, patients can live between 12 to 16 months. But actually, in my clinical experience, and when I've been following the patient with Dr. Valerio, when I follow the patient with Dr. Walsh, we have couple cases that was diagnosed with GBM, and they have a very good survival rates, around 36 months, 48 months. So
Really?
that's what I say. Each case, each person is different.
Right.
So that's why protocols are very important, and I like to do it. But at the same time, we need to treat patients, not protocols. So that's why if we need to improve the quality of life, we need to evaluate each case and try to use the best of the technology to help and support the outcomes.
Thank you.
Very good. Poco.
I would really like to see more of your presentations in the future. Thank you very much.
We will. You'll see Andres, and Andres, I hope we can get this community of Latin neurosurgeons together, and I'm sure Louis, and you will see a little bit of each other. Louis has done 3 or 4 hangouts with them. Louis is you won't meet too many neurosurgeons like this, Andres. He's a triathlete. Andres is a neurosurgeon, Louis, in Miami, but he's up in Johns Hopkins doing a fellowship right now.
I joined
Oh,
Johns
that's
Hopkins,
nice.
yeah. I joined Johns Hopkins more as biotechnology and neuro-oncology. It's a candidate master degree there. They have a very good program in biotech, but they do the part of neuro-oncology. So that's why I received the invitation just to do it's a master degree actually, something that is very important actually when you practice with that type of topics. That helps to do better clinical practice and to understand many things that in clinical is very hard to understand. So I love research, so that's why I took the opportunity to do it.
And you'll be going back to Miami after you're done?
Yeah, I'm in Miami. Right now I'm in Miami. I'm in Miami right
Oh, you're
now.
still in Miami. Okay,
Yeah, I'm still in Miami. Yes,
okay.
I'm still in Miami. But
Okay.
what I say, sometimes I have to go there, but just for a couple of days.
Oh, okay.
Actually, right now with the technology, we can do many things online. So that's perfect.
That's very good. Okay, we'll continue to be networking with you, Andres.
Great.
And we're going to do a hangout now with Louis. And if you want, you're
Nice.
welcome to hang out. But if you want to go home, that's fine too. And I appreciate your effort you made to go to the library to do this presentation. That's great. Thank you very much.